like to invite on stage Andras Palfi. He is a data scientist at Bigstep, and his presentation will focus on how automation is changing machine learning and data science. Thank you.
Hello everyone, thank you very much for being here. My name is Andras and I am a data scientist at Bigstep. I got a confession to make first of all. I had this talk 2 days ago to a very non-technical audience. So I think some of the parts might be a bit already known to you, so I'm going to try to skip them and focus on the more technical ones. So what I would like to do with my presentation is take all these frameworks and all these tools and technologies that we have seen today and put them into a context of automation and its effect on data science. So, as you have seen today as well, automation is a very black and white topic. Actually, it was more black today than white, because it's black and white because generally almost any forecast or article you read about how automation is going to affect our future can be put into one of two narratives. And one of them is that it's just another wave of automation, that it's definitely going to lead to a better future, just as it always had since the Industrial Revolution. I mean, sure, some jobs are going to be destroyed, but new ones will be created, and not just new ones, but better ones. On the other hand, the other narrative is that this time is different. The robots that we have now are becoming more and more capable and more intelligent. And because of that, the number of jobs and industries that they're going to destroy, it's going to far outnumber the number of jobs that they create. And I enjoy these forecasts because it's usually they're made by two different types of people. So technologists usually take the view that this time is different, and automation is definitely going to lead to a loss of jobs, while economists are the ones that are taking this more positive view. And as you know, economists are really good at making predictions. If you remember, they were also right about 2008 and saying that house prices are never going to fall down. So we don't know what's going to happen in the future. All we know is to look at what's happening now. And what's happening is gradual automation. And this can be illustrated with the process of driving, because for many years now we have been taking small parts of the driving process and automating it. And we started out with these simpler tasks like cruise control. And then we gradually took upon more complicated tasks, like we developed the GPS for route planning, and then now we have automated braking systems. And of course, it's certain that in a couple of years, 5 to 10 years, we're definitely gonna have autonomous cars. So what does this process tell us? What can it teach us? Well, it's that automation happens in steps. It's gradual. It doesn't go from human to all of a sudden robot. It's this gradual process. And this can be applied to many jobs. The only difference is the time frame at which it happens. Of course, if you're a doctor, it's going to take a long time until large parts of your job are automated. On the other hand, let's say if you are a security guard, then this time frame might be much smaller. Of course, there's already a company in Silicon Valley that has developed these small R2D2 size security guards that go around these big American parking lots taking pictures and filming things. And just as a funny story, one of these robots, I think it was his first day on the job, ended up committing suicide. So maybe if you're a security guard, your job is still safe. So this process of gradual automation, as we have seen, I think, today as well, is happening in data science as well. And I would like to focus on two different parts of it. First is these platforms, data science platforms. And the second one is automated machine learning. And they're definitely interconnected. So I'm not going to bore you with the definition of data science. You probably all know that already. But, and you know that extracting information from big data sets can be expensive. And that's because in order to develop any type of advanced analytic projects, you need to have this data infrastructure first. And for many years, building this type of infrastructures was like building a car just from parts. You could do it, but it took you expertise and time and also a lot of money. And fortunately, what we have now is these technologies that can make this process much easier. So a little bit of shameless self-promotion here. This is exactly what our company is doing as well. We have a platform that makes it very easy to put together these big data infrastructures. And I really like what Ted Dunning said this morning, that they can take care of the plumbing of data science. So, but even though that they do that, you still need, they're still just an infrastructure. They still need a data scientist, somebody who write lines of code to manipulate the data and build machine learning models. And if you're a data scientist, you already know that that can be a time-consuming and a painstaking process. And to see why, let me walk you through the data science workflow. So I'm sure you noticed that you already know that it's basically every data science project can be broken down into 3 different parts. And those are processing, model building, and deployment. And each of these parts has its own inefficiencies. Starting with data processing. In data science, we have this rule of thumb that 50% or 60% of a data scientist's time is going to spend just manipulating the data. And as you can imagine, that's a very inefficient use of a data scientist's time. So any type of automation that we can bring into this part is going to bring a tremendous amount of value into data science. And model building, not necessarily time consuming, but it's a very tedious process. And that's because you never really know beforehand what type of machine learning model is going to work best for a specific problem, a specific data set. And because of that, all a data scientist or a machine learning engineer can do is to test out all these large number of machine learning pipelines and machine learning models and see which one works the best. And first, there's a lot of issue with that process. First, because it's hard to keep track of all these models and all these hyper parameters. And the second one is also time consuming, and also there's a lack of knowledge as well. It's happening. Usually a data scientist doesn't know all the existing machine learning models and all the existing pre-processing steps and all the data imputation models. Another source of inefficiency happens in deployment. And I really enjoyed the talk given by Alteryx, where he explained that data science is useless until you actually put the model into production. So it's not going to help anyone if a data scientist develops the coolest machine learning model and then keeps it on his laptop or keeps it on GitHub. So these models need to be deployed, need to be integrated into the business. So this is where a new type of platform comes into play, and we can think of these as sort of software that have taken all of this data science workflow and put it into a single platform. And that's what Alteryx is a good example for a company who's doing that. Another one is H2O AI, but I'm sure you heard of the rest of them as well. RapidMiner, I think, Nime is another good example. So what they're really good at doing is providing all these tools for data scientists to automate large parts of this workflow. Like, for example, I used Alteryx, and it's very good at blending data sets and inventorying data sets as well. Of course, these data science platforms only take you so far. You still need a data scientist to create you, or a machine learning engineer to create you these models, these predictive models. You still need this knowledge. And I think almost everybody has said that today, that this knowledge is not easy to find. And once you find it, it can be expensive to pay for. So this is where a new type of algorithm, because these are basically algorithms, a new type of algorithm comes into play, and those are automated machine learning algorithms. So what these algorithms do is basically they automatically can go through a large number of machine learning pipelines, machine learning models, and choose you a couple of really good performing ones. So basically, these are the type of algorithms that are touted as the ones that are going to kill all the data science jobs. I'm going to come back to that idea a little bit later on and see if that is indeed the case. But right now I would like to talk to you a couple of interesting open source projects that are happening within automated machine learning. So one of them, this is a library that I myself have tried. It's called Feature Tools, and it's based on research done by MIT. So basically what this, it's a Python library. Basically what this library does is automated feature engineering. It can automatically build you a large set of statistical features. So what do I mean by that? If you have a lot of data in different tables that are somehow interconnected, think of it as having client data. You're a bank and you have a client, and you have all these tables that are about either transaction history or about credit history or internet banking history, and you want to connect them into a single sheet of features. So what feature engineering can do is you set these rules about how these different tables are interconnected, and it's automatically going to build you a large set of statistical features like min, max, sum, standard deviation. So why is this good? Because feature engineering can be a very time-consuming process, because usually you need to engineer these features manually, first of all. Second of all, it takes domain knowledge. You have to know beforehand what type of feature is going to be the best helpful is going to be the most helpful for your model. So can this tool replace domain knowledge? No, it cannot. However, it can help you build a very good baseline model just by going for quantity instead of quality. Of course, it's going to give you this large set of features, so you're going to have to do feature selection yourself. And the next two projects I would like to talk about are effectively automated machine learning libraries. So, and these are all based in Python. So if you're a Python programmer, you can try them yourself. They're based on two very different technologies. TPOT is based on genetic programming. I read their paper. To be honest, I don't fully understand how it works, but I definitely tried it out. And in basically just one line of code, it's going to go through all of these different machine learning pipelines and try to incrementally get better and better models. The other one is based, the auto-scikit-learn is based on something called meta-learning. So what they have done is they have tried out many different machine learning models and looked at which ones work best for certain type of data sets. And they calculated all these meta features for these data sets. That means how these data sets look like. So they took note of how the data sets look like, meta features, and what type of algorithms work best for them. And they're trying to reuse this knowledge anytime they're training a new machine learning model. So basically, you're going to give it the data, it's going to calculate some statistics on it, some features, and it's going to look back at what type of models work best on this type of data set, and also what type of hyperparameters work best on this type of data set. So but basically, it doesn't have to start from zero, searching for these machine learning pipelines and models. So I have tested both of them. They're very easy to use. And what's the biggest benefit that they can bring right now? And I'm going to give you an example. So I was working on a churn model, and I spent a couple of days cleaning the data, putting together all these all these cleaning pipelines, and then going through a couple of models, I think 3 or 5, which are my favorite models, and came up with a pretty decent ensemble of models and pretty decent score. I think that's what I thought. So I was very happy that I'm such a good data scientist. But then I thought, but let's pit myself against one of these automated machine learning libraries and see what happens. Am I better than a simple algorithm? So what ended up happening is it actually, with one single line of code, in like 30 minutes, auto-scikit-learn went through all these models and came up with a pipeline and machine learning model that was just slightly worse than what I have done. So what that goes to show is even though if you can develop a very good machine learning model, they can save you a lot of time. And of course, these are limited to simpler problems. Like churn is, if your data set is small and your problem is not that complex, then these automated machine learning libraries can definitely help you. They also, another useful way to use them is look at different pre-processing pipelines and imputation that they do, because I learned from them techniques that I never even knew existed. And they said that, okay, look at these techniques, they're working good on this model, try them yourself. So they can help you fill in some missing knowledge. Okay, so we have seen what these automated machine learning algorithms can do. So does that mean that they're going to fully automate data science? I think definitely parts of it are going to be made much more accessible to people who aren't data scientists, aren't machine learning engineers. So I'm talking about business analysts, traditional business people, marketing people. These tools are going to be very easy to use and very efficient, very time efficient, and very money efficient for simple problems, like I was telling you, like churn. I think another problem that they use, H2I uses them for, and Alteryx as well, uses them for fraud detection. These are very, very well-defined problems. So it's easy to just drop some data into them and get a decent working model out. But can it be fully automated? Let me try to answer that with a short story. So during the Second World War, there was this mathematician called Abraham Wald. Some of you might have heard this story, who got asked by the United States to work on military projects. So what his job basically was, he had to figure out a way to prevent military airplanes from being shot down. So as a good mathematician, as a good statistician, he started gathering all this data and looking at all this evidence. And what he found was that all the airplanes that were coming back were full of holes everywhere, on the fuselage, on the wings, everywhere with the exception of the engine and the engine casing. And so he got all this data, and he went to present it to the Air Force. And of course, the Air Force, seeing this, they said, well, the solution is easy. Just slap more armor on the places that are heavily damaged, and just make sure that these airplanes are still going to be able to fly. So, however, Abraham realized that although that sounds very intuitive, that's not the right approach. And that's because of this thing called survivorship bias. So what it means is basically they only had access to parts of the data. And that data was all the airplanes that were able to survive the battlefield. And because of that, they realized they shouldn't be looking at the places that were full of bullet holes, because still those airplanes managed to come back. Instead, they should be putting more armor to the places which weren't covered by holes, because those were the planes that were getting shot down on the battlefield. So this goes to show you that data science is not just plugging some data into models and some data into machines and just then getting the model out. It's more about critical thinking. As a data scientist, with the help of these platforms, these data science platforms, and with the help of automation, data science is not, as a job, not going to get destroyed. It's going to gradually shift towards not spending your time in all these very time-consuming tasks, like manually programming these machine learning models. It's going to go towards understanding how data science as a whole can affect your business. How can you use, how can you evangelize the use of data science within your company, for example? I think that's mainly it. So if you have any questions, I'm more than happy to answer them.
Question? Anybody? No? Oh, okay.
Thanks for the talk. You've mentioned the two auto modeling libraries. I was wondering what is the real output of them? Because I'm always afraid that like our technology gets more boxed. We get this magic single function, but don't really understand what the output is. And then probably we need to make this final tweak or two to the algorithm, which the library won't do for us. So I wanted to ask how well the output form for those libraries is handled. Yeah, is it easy to figure out what's going on there?
That's a very good question. They give you a pipeline. So basically they give you the whole machine learning pipeline in Python. So you can see what type of pre-processing steps, what type of models, what type of hyperparameters were used. So you basically get the model. But still, that's just lines of code. So somebody still needs to, yeah, exactly. That's another part where data science is going to shift to, like explaining what these models actually do and understanding which variables are the most important one. Also understanding, like Daniel was telling us this morning, understanding issues about bias as well. So they definitely, you still need, yeah, exactly, definitely still need to understand these machine learning models. But to come back to your question, they put out a pipeline that you can basically copy and then just use in production.
Thank you for the talk. I just noticed that you only mentioned a couple of automation libraries.
Yeah.
Was that just for the sake of time, or had you looked at other ones like MLBox and AlphaPy, or the new ones based on network architecture optimization?
No, I know. I only spoke about these ones because these ones that I actually tested. But I think, yeah, there's one called AutoWika that is implemented in R, and there's definitely ones that do these architecture search to find out the best architectures for deep learning models. I think Google has come up with a technology like that.
So it was really just because of your
Yeah, it's just because of my personal experience that I used these two.
Any other questions?